Now we want to take a look at the geometric interpretation of our dot product. So if I have two vectors that I take the dot product of, there would be an angle representing this value. So we want to find the angle theta that results between the two vectors that I am taking the dot product of. So here is a formula that is given to you. Notice that when I take the cosine of some angle theta, that's going to be equal to, in the numerator up here, I have the dot product between the two vectors I am working with, divided by the magnitude of the first vector times the magnitude of the second vector. So let's go ahead and practice an example and apply this formula right here. So we have three things we're going to do. First, in this example down here, I want to take the dot product of my two vectors. So vector u dotted with vector v becomes 3 times 2, which would be 6, plus 4 times 1, which is 4. So the dot product of u dot v is 10. Now the next thing I need to do, and it's kind of hiding up here, but the next thing I want to find are both the magnitudes of u and v. So I want the magnitude of u. Remember, when we take the magnitude of a vector, we take the square of the first term, add it to the square of the second term, and the square root of that sum. So 3 squared plus 4 squared ends up being 5. We're going to do the same thing, finding the magnitude of the vector v. So we're looking at the square root of 2 squared, which is 4, plus the plus 1 squared, which is 1. So I'm taking the square root of 5. So these are the components that I'm going to put into my calculator, or I'm going to use to find the angle theta. So if I were to write the cosine of theta is equal to, remember the numerator was the dot product, so that's 10, divided by the denominator, which is the product of my two magnitudes. So 5 times the square root of 5. So I can find out what theta is by taking the inverse cosine of those values, or of that number, on my calculator. I think I better go over this with you on your calculator just to make sure you enter it in correctly. So I'm going to pull my calculator up and we're going to do this one together. So on my calculator, I'm going to take the inverse cosine. So I choose inverse or second cosine, and I need to put this information into my calculator. Remember that order of operations tell me that the numerator is 10, and I am going to divide that by what's going on in the denominator, which is 5 times the square root of 5. So I need to surround the denominator in parentheses in my calculator. So it's parentheses 5, and then times the square root of 5, arrow out from underneath the radical and close the parentheses for the denominator and close the parentheses for the cosine function, or for the inverse cosine function. So your calculator should have two parentheses facing that way, or facing right, and I have two parentheses to close them off facing left. So when I hit enter for this value, you can see that the cosine, or in other words theta, is 26.57 degrees for the value that I end up with. And we'll just drag that over and put it on the notes. And that would be the value that we end up getting. So let's try that one more time. Okay? We're going to try that one more time with this right here. So if I wanted to know what the angle theta was between these two vectors, u and v, first I need to find out, well, what's the dot product between u and v? So u dot v would give me 2 times 6 is 12, plus negative 6 times 2 is negative 12. So that's just 0. Now the formula for theta, and we'll just write it as theta, solving for theta, would look like the inverse cosine of the numerator, which is dotted, divided by the magnitudes, right? The magnitude of u times the magnitude of v. Well, if my numerator is going to be 0, then I don't really care what the denominator is. I can stop right now and I can say, because 0 divided by anything is going to be 0. So when I take the inverse cosine of 0, you get back 90. And that's how you take the that's how you find the angle theta between two vectors that you're working with.